Okay, today we're going to look at how do you find the length of a curved line or arc length. One way we could do it is like take a string or something and kind of put it on there as best as possible and then pull the string straight and measure it, and that would give us an approximation. But is there a way we can use math to actually find it? And there is. So what we're going to do is think of this curved line as split up into line segments that kind of approximate that curve. So here you can see there's about seven segments here that are approximating that curve. It's okay, but not great. But it would give us a decent approximation of it. Well, what if we take that a step further and divide those line segments into even smaller line segments? So, for example, right here, if we just took that one line segment and now split that one into two and then into three and then to four, and what if we kept doing that as the number of line segments went to infinity? Well, then we would write that out with a limit. So we would say the limit as the number of line segments goes from 1 to infinity of the difference of these, because the difference of this point minus this point would give us that distance there, so that and we do it with absolute value to make sure it's positive, but the summation of all those would give us the distance of that line. So what we're going to do then is apply mean value theorem to it to come up with an actual function to figure out what this is going to be equal. So remember, mean value theorem says a derivative is equal to your x values, or your f values here, at f of a minus f of b over b minus a. So what we're going to do here, or what happened here, is instead of using b and a, they're using two x values here, which b and a are x values. So they're saying one of them is x of I, and the other one is x of I minus 1. So here we got x of I and x of I minus 1. So one thing they did here to get to this statement is they multiplied both sides by this, so this got multiplied and brought over here. So that's written right there. You got your derivative times the difference of your x values. On the right side, then, what would be left is this. So next, what we know is the difference of our x's here. That would be our change in x. F, another way to write f is your y value, so that's our change in y. So now what we're going to do is use that statement and find the length of the line by using distance formula. That's what this is distance formula. So it's just using Pythagorean theorem there, square root of the two values squared to find the hypotenuse. So we get that by doing our change in x squared plus our change in y squared, and then taking the square root of it. Well, our change in x squared, we still have. Our change in y squared right here, we know from up here is equal to this. So that got substituted in. So now if we square that, we would end up with, do it one more step here. If we squared both of those, now we got square root of change in x squared here. On this side, both of these would be squared, so you got the derivative squared and another change in x squared. So what they did, since there's one here and one here, it got factored out. So if you factor it out, you got change in x squared. If you factor it out here, we just have 1 left, 1 plus the derivative squared over here. And then if anytime you got two things multiplied in a square root, you can pull one of those out. So that's why that's pulled out there of that other one. They just separated this. Just like if we had square root of 50, and we know that's equal to 25 times 2, we can separate that to square root of 25 and square root of 2. All right, so then the last thing that they did here now, the last couple things here, if we got square root of something squared, that would just be equal to change in x. Over here, this is what we got written here, and that becomes then our way of finding the distance of a curved line is the square root of 1 plus the derivative squared times our change in x, and then we're going to integrate that from a to b. And that would give us the distance of that line. But one thing we got to make sure, the derivative is continuous. You got to make sure that it is continuous on the length from a to b. As long as that's true, this equation then will find the arc length. A couple ways you might see it written. They might use this notation for derivative. Some books you might also see this other notation for derivative. They both mean the same thing. But that's how we're going to find out our arc length.